This question asks, imagine you are conducting a Fischer esterification reaction as shown below. If the alcohol reactant contains 100% 18 oxygen, indicated with an asterisk, which oxygen atoms do you expect to be 18 in the product molecules? So this is essentially asking us, where does this oxygen atom in the starting material go? So we have propanol, and the oxygen of the propanol is labeled with O18. And so in the mechanism, where does this oxygen end up? So this is at its core kind of a mechanism problem. So let's kind of think it through. Whenever we have the Fischer esterification, we're going to start with the carboxylic acid and use acid catalysis in order to push the reaction forward. So in this instance, we're going to add a hydrogen to the carbonyl oxygen here. This is going to create a strong electrophile. And then we can have the alcohol come in and attack. So the alcohol is our nucleophile. So I'm going to label the oxygen atom blue here in my drawing, just to kind of highlight it. So it's going to come in and attack. We open this up here. To make an alcohol. There's the labeled oxygen. And note that here it's got a charge, so we have to neutralize that charge. A base will come in and deprotonate it. And so the neutral intermediate that we form is going to look like so. And I'm going to draw in the blue oxygen. Like that. So this is kind of our neutral intermediate for the Fischer esterification reaction. From here, what happens is we're going to work on eliminating one of the hydroxyl groups. And so the way that that works is in the next step, we're going to protonate it, again with acid. That makes a good leaving group, which is water. And we're going to kick it off. So we do that by pushing one of these lone pairs down and kicking out the water. That makes this molecule. And we have a plus charge right here. And then the very last step is just deprotonation to make our neutral ester compound. So I'm going to add an arrow going this way. And note too, all of these arrows are like really equilibrium arrows. I'm not drawing them as equilibrium arrows, but they are. This is an equilibrium. So our base will come in and deprotonate. And our final product looks like this. An ester as depicted in the products. But here we can kind of really see what happened to that original O18 label. And it only really shows up in one place. The oxygen in A is kind of always present on the molecule and it doesn't really move. Actually, I'm going to use a different color to highlight that. So A was kind of always present. And then the C oxygen comes from the oxygen that was part of the carboxylic acid. And so only B, oxygen B, is the one that was labeled with the 18 at the beginning of the experiment. So if we're thinking about, how to answer this question, again, it asks, which oxygen atoms do you expect to be O18 in the product molecules? And after kind of looking through the whole mechanism and keeping track of the oxygen atoms, the only answer that works is B only.